What if I told you that right now, particles inside your body are literally walking through solid walls? Not metaphorically. Not theoretically. Actually, physically passing through barriers that classical physics says are completely impenetrable. This is quantum tunneling, and it's one of the most mind-bending phenomena in all of science, and it's also why you're alive. Let me explain. In classical physics, if you roll a ball toward a hill and the ball doesn't have enough energy to get over that hill, it stops. Simple. But in the quantum world, particles don't play by those rules. An electron or a proton approaching a barrier doesn't need enough energy to go over it. It can simply appear on the other side. And before you say that's impossible, the sun is powered by exactly this process. Inside the sun's core, the temperature is about 15 million degrees Celsius. Sounds hot, right? It actually isn't hot enough. The protons inside the sun don't have nearly enough thermal energy to overcome the electrostatic repulsion between them, a force called the Coulomb barrier. By classical physics, nuclear fusion inside the sun should be essentially impossible. The protons should just bounce off each other forever. But quantum tunneling changes everything. Because protons are also waves, thanks to wave-particle duality, their wave functions can overlap and penetrate through the barrier even without sufficient energy. The probability is tiny for any individual proton, but there are roughly 10 to the power of 57 protons in the sun, so tunneling events happen roughly 10 to the 38th times per second. The sun has been fusing hydrogen for 4.6 billion years entirely because of quantum tunneling. Without it, no fusion, no sunlight, no life on Earth. Period. But it doesn't stop there. Your own DNA replication depends on quantum tunneling. In 2014, researchers at the University of Surrey published work showing that protons in hydrogen bonds between DNA base pairs can tunnel from one strand to the other, potentially causing mutations. This is called proton tunneling, and scientists now believe it may be a contributing factor in spontaneous genetic mutations, some of which drive evolution itself. Quantum tunneling is also the principle behind the scanning tunneling microscope, invented in 1981 by Gerd Binnig and Heinrich Rohrer at IBM. They won the Nobel Prize in Physics in 1986. This device can image individual atoms by measuring the tunneling current of electrons across a tiny vacuum gap. It gave humanity its first direct visual confirmation that atoms are real discrete structures. In modern computing, quantum tunneling has become a serious engineering headache. As transistors in microchips shrink below 5 nanometers, and today's chips from TSMC use 3 nanometer processes, electrons start tunneling through the gate oxide layer uncontrollably, causing current leakage and heat. This is actually one of the fundamental physical limits on how small we can make classical transistors. The same phenomenon that powers the sun is now threatening to end Moore's law. Researchers at MIT and Stanford are exploring quantum tunneling transistors, devices that harness tunneling deliberately to switch states using far less energy than traditional transistors. If successful, it could unlock processors that are both faster and orders of magnitude more energy efficient. The weirdest part of all this? Quantum tunneling is instantaneous. In 2020, physicists at the University of Toronto measured the tunneling time of rubidium atoms and found that the time spent inside the barrier was effectively zero. The particle doesn't travel through the barrier, it simply ceases to exist on one side and appears on the other. Einstein called quantum mechanics spooky. But spooky or not, it literally keeps the lights on.